This is the walkthrough video for PCTC 2022, round 2, question 8, list code. Okay, so we're given this list input, and we essentially need to go through this random algorithm so that we decode it to eventually get this. And what's the decoding like? Well, as we finish a list from left to right, so we go through this and we finish a list, for example, this is the first list we finish, then we take all of the digits in that list, only the digits, and we calculate the mean of only the first digit and only the last digit. Or in the case of this list, for example, there is only one digit, so we calculate the mean of 3 and 3, which is just 3. But yeah, anyway, I'm going to take what I think makes the most sense to me, which is a recursive approach. If you understand recursion, then this question, then my solution should be relatively straightforward. If you don't understand recursion, or you haven't had much experience with it, then the solution is going to be quite difficult. And if you've never come across it before, I recommend going to try and look for another YouTube video to try and learn that first. Because recursion is a really difficult concept for you to get across, for you to understand as a human. But once you do understand it, then questions like this become so much easier. Okay, so let's take in our input. Let's call it list. And this is actually just inputted as a string, which we don't want. We want it to be a list. And so to convert a string into a real Python thing, we use the eval command. Eval just stands for evaluate. And essentially, so far on line 2 of our code, list is basically equal to that string. And what the eval does is it will make list now equal to this. So it you can kind of think of eval as if it just removes the 2 quote marks on either side of your string, and that's all eval does. And that's what we want, because now we're left with a real string, a real list, which is what we can use to do our recursion. So let's call our function func, and in it let's pass a sublist, or we'll just call it sublist. And when it comes to recursion, there are always 4 things you need to think of. So the first thing is, what am I inputting? So what are the inputs? The second thing is, what is the base case? The third thing is, what is the recursive case? And the final thing is, what do I actually want to do? What do I actually want to do or return? So the first one's the easier one. What are the inputs? In this case, we're only going to have one input, and that's just going to be our list. So we're going to input a list into this function, and this function is just going to do whatever it needs to do to process that list. What is the base case and what is the recursive case? So these two can be answered together. The recursive case is as we go from left to right in our list. So as, for example, if this is our input, as we go from this to this to this and so on. So each of these are elements in this outer list. So as we go through each element in the outer list, if we come across a digit, we're going to say that's the base case. If we come across another list, this is the recursive case. And this makes sense, right? Because our input, for example, is list within list within list within list and whatever. And that's recursion, right? Recursion is something within something else and so on. And so our recursive case is simply just going to be the thing that's in something else. So our recursive case is if we ever encounter a list within another list, and then we just recall we recall our recursive function with that sublist of the list. So let's do that now. So for thing, or I guess, yeah, let's call it thing. So for thing and sublist, so we're just going through every element in our sublist, and our recursive case is going to be if our thing is another list. And so to check if something is a list in Python, we can use the isInstance idea, and then say thing and list. And what this does is it basically checks if this variable is equal to this type of variable. So for example, we can change this to int, and it would check if the thing is an int, or a string, and it would check if the thing is in string. But in this case, we want to check if it's a list, so let's just keep it a list. And this returns true if this is a list, and false if it isn't a list. So if it is a list, then let's recall our function with our even smaller list called thing, and that's our recursive case done. Now our base case is going to be, if it's not a list, then it's going to be a string. Sorry, it's going to be a digit. And we can have an else there, right? Because every element is either a list or a digit. And so if it's not a list, it's going to be a digit. So we can have the else there. And what do we do in our base case? And this is where the 4th point comes in, which is, what do I actually want to do? What do I actually want to achieve in this function? And I want to achieve, well, I want to figure out what the mean of the first and the last digits in our list are. But to do that, I need to know what the first and last digits of the list actually are. And so I need to keep track of them. And so let's create a new variable at the start of our function called new list. And every time we encounter a digit in our list, let's append that to new list, like that. And so all of a sudden, we've kind of almost completed our 4-step guide to recursion. But a couple of things to note. So just to kind of emphasize what this code does, it means if, for example, our sublist at the beginning of this function was equal to that, by the end of the function, it's now going to be equal to, well, it's going to be equal to the same thing, but new list is going to be equal to, basically everything, everything that isn't a list. So new list is going to be equal to this at the end of our function. Because if you think about it, we're going through each of our elements in our initial list and only adding it to new list if it's a digit. So it only adds the 4. It doesn't add this list. It doesn't add this list. It only adds the 8, then it only adds the 6. And so new list by the end of our function is just equal to a list of every digit of that list, which is what we want, right? Because it says, for example, we want to ignore the sublist within the biggest list whilst calculating the averages. And so let's actually calculate the average. Well, that's just going to be whatever the first number is plus whatever the last number is, which is -1 in our list. And to calculate the average, we take all of that and we divide that by 2. But we don't want to just do this division by 2. We want to do integer division by 2, which is 2 dashes, because we only want to deal with integers. If you look at the example output, all of these are only integers. There's a 5, there's a 3, there's a 7, and there's a 5. It's not 5.0 or 3.0 or 7.0. These are all whole numbers. And so we only want to deal with whole numbers. And integer division returns a whole number, whereas normal division will return a decimal number or a float. So the answer would be, for example, 5.0 as opposed to just 5. And we know this is valid because up here it says all averages calculated will be whole numbers. And so we know we are still calculating the correct average, even if we're integer dividing it. Okay, so that's pretty much our function done. Now we need to keep track of our answer. Like, we need to do something. We've calculated this average, and now we need to do something with it. And what we want to do with it, we want to add it to the end of our decryption code. And so let's just create a new variable called answer, make that a string. And the reason I'm making it a string is so I can then concatenate the answer to this to the end of the string. So we're just adding this to a string. You can think about this as, you could have just done this as a list, right? Like, answer could be a list, and you could keep appending the average to the end of the list and then format that and print it at the end. But that's the issue. You have to bother formatting it. I don't want to have to spend time formatting it when I can just treat it as a list. So this is a more efficient method, or a faster method to code, if you want to output this format. But of course, you can't add an integer to a string. So let's just convert that to a string, and then we can add it and concatenate it to the answer. And then let's call our function with our initial list, which is just list. And then finally, we need to print out the answer. And one other thing we need to do is we need to add a global variable called, or we need to make answer a global variable. The reason we make answer a global variable is whenever you modify a variable within a function, that to save the modified variable, you need to make sure that variable is global. So even if I add stuff to answer here, if I didn't have my global answer thing here, it wouldn't work, right? Because as far as Python is concerned, I never changed the variable answer. And so to make sure it knows that I've changed the variable answer and it saves that and it prints the correct thing out here on line 20, we add global answer at the start of our function, and that just makes answer a global variable. And so we should be able to submit that code and hopefully get all of those points. Lovely, yeah. So yeah, this question was like, it's only like 20 lines of code if you know how recursion works and you're familiar with recursion. But if you're not, then it's going to be obviously much harder. But yeah, this question hopefully should scream recursion to you as soon as you read it, because you see lists within lists. And crucially, the fact that the reason recursion is useful is because you only evaluate a list as you go through it from left to right. So recursion is like equivalent to the graph algorithm depth first search, where you go as deep as possible. And that's kind of what we're doing here. We're going as deep as possible from left to right. So for example, we evaluate this list before we evaluate the entire whole list. And that's why recursion is useful, because it evaluates the list in the correct order, and therefore it adds the digit to answer in the correct order, and that's how we get all 10 points. But yeah, if you follow that four step checklist, what are my inputs? What do I want to achieve? Slash, what's my output? What's my base case? And what's my recursive case? If you answer those four questions in any order, then recursion becomes so much easier because it's fundamentally just a few basic things all tied together to make one complicated function.